Welcome to Programming in Modern C++. This is another two-part series of tutorial to give you an idea about how to mix C and C++ codes. Due to legacy and reuse and several business compulsions, we often need to mix C and C++ codes in the same project. So, what we are primarily studying in the course modules is either how you do a C project or how you do a C++ project, but in reality you may need to do a mixed language project. So, in this tutorial and the next, we are going to discuss what are the issues of mixing C and C++ programs or C++ codes in the same project, and what are the ways to handle that, what are the resolutions, and we will also in the next tutorial work out a detailed example for your complete understanding. So, this is the outline, will be available on the left, as you know. So, first let us look at what are the different aspects of mixing C and C++ code, starting with why at all we need to mix. Now, the primary reason for mixing C and C++ codes is legacy and reuse. As you know that C has been around from much earlier than C++, and also till date C is the most widely used language in the community. So, there is no exact known quantum of how much of well tested C codes exist, but it is estimated to be over trillion lines. Trillion, you understand, million, 1000 million is a billion, 1000 billion is a trillion, right. So, reusing them and or with C++ needs mixing of code, because certainly if there is a well tested C library, I would not like to re-implement that if it serves my purpose. So, and it is also that mixing of C and C++ is not a specific issue between these two languages because they are siblings, but it may be used across various pairs of languages like C and Python, or say C# and Python, or C++ and Java and so on, to harvest the best features, best benefits of both languages. Like we know C, C++ are primarily known for their efficiency. In addition, C is lightweight relatively and easy to use in embedded programming. We have discussed these things in the main course module. Python has rich libraries, it is good for the web, Java is good for applications with GUI and so on. So, we should, in general, the community of programmers try to mix languages if it is giving a specific benefit and use those proven libraries. And actually in several projects we may mix more than two languages as well. Now, there are obviously several articles on projects using multiple languages, because I am sure when you hear from me that this kind of multi-language programming, often referred to as polyglot programming, are people really doing it? So, here are some references where you can see the variety of small, medium and large projects which use the mixes, but we will restrict our discussion only to C and C++ mix. So, if we want to mix, then there are typically two situations. One in which both C header and the C source file are available and editable, and the other where only C header file is available. Now, if an existing project that needs to be migrated to C++ in full or parts to be reused, there could be two options. One is certainly we can mix the C and C++ code, that is whatever we want to reuse from C, we take that, compile it by C compiler, and whatever we are using from C++, we use C++ compiler and then link by C++. I have left it with a question here as to why do we link by C++, not by C, and the discussions in this tutorial will give you a comprehensive answer to that. The other option would be to build everything in C++. We have been taking C is a subset of C++. Well, it is true and it is not true at the same time, and we can build both of them, C and C++ code, with C++ compiler, that is say G++, and link. Right. So, this is a typical options where we can we have the header and the source file and are editable. They are editable in C. Now, if we have C header files only, not the source file, that is third party source is already pre-compiled, available as an object binary. So, the third party just does not give us the implementation of the headers, it just gives us the header file. This is typical what you get to see in the standard library situation also. You just get the header file, not the implementations in the source file. And further, it may also happen that the header file itself may not be editable. Header file you need, otherwise you would not be able to use that code, but the vendor may mandate that you cannot edit the header file, and which is exactly the case for the standard library and could be for any third party library that you use or you want to build. So, for example, what are the situations, very typical situations you need that. For example, you want to write a C++ program or library that does scientific calculations. I am not sure if you know, there is a GNU library called GSL, GNU Scientific Library, which is written in C, and it is a very rich library in terms of scientific computations, very rich set of functions, obviously lot more than what your math.h has, lot more of complex functions, different types of defined data type structures in C and so on, and well tested, very efficient. So, if you are writing something for scientific calculation, it is always it is most often at least advisable that you use this GSL instead of writing the code from scratch and going through all the pains of development. There are a lot of C games, game codes efficiently written in C, which you want to use with the C++ graphic engine to make the whole thing work. So, that could be, I just picked up two somewhat common examples, but there could be several situations where you would have that you want to use the C code in C++ project and you have only a header available, and which by itself may not even be editable. So, we would like to often wrap the C functions for use nicely in C++ type functions. C functions have certain limited capability. For example, they do not support exceptions, not as richly as C++ does. They do not support very common data types like string, which you have in C++. So, you might so the function if it has to return conceptually a string, it will return a C string, that is char star or const char star. But you may want to have a wrapper which takes that char star and converts it into a std : string, so that it can very seamlessly work with the other C++ codes, other C++ functions. The same thing can be said about the parameters that you pass. So, here the option only is to mix C and C++ codes. So, as we can see from the two scenarios here, that in both scenarios you can mix the codes, that is compile C by C compiler, compile C++ by C++ compiler and link by C++. And in one case you have the option of building everything in C++ as well. So, let us see what are the different perspectives under which we will choose which pathway to take. Is it only based on availability and editability of header and source, or there are other factors that are involved? So, first let me focus on what if I build the entire thing as C++. Right? So, naturally you build everything with C++, use G++, which compiles everything by C++ rule, and naturally links by C++ linking. So, that eliminates the need for mixing. Right? Now, the point is, however, we might think that C is a subset of C++ and so on. It is often not easy to build a C code by a C++ compiler, unless that C code strictly uses the common subset between C and C++. Right. This concept is somewhat maybe sound like a jerk to you, but that is true. There are certain features in C which does not work in C++. Right. That's the reality. And we have separate tutorial on compatibility of C and C++ languages where we talk about these and give you examples to expose you with what these issues are. So, consider a simple C program here. So, you have a call to square root. I mean, we just ignore the fact that math.h has not been included, that will need to be included. This is just for the illustration. Then you print the size of character A, you define some void pointer and do implicit casting, put values and so on. So, some few this program by itself is not meaningful, it is just trying to illustrate the issues. So, here of course, math.h is missing, as you can see. So, in C89 this will be a warning, because glibc or libc in general will have that, and GCC at least and many compilers would by default include the header that is required, but it is an error in C++ 98. Right. So, the first thing is well, this is editable, but you will still have to bring in math.h here and edit. Right. Now, interesting things happen when you try to print the size of a character. A character is considered a char is considered an int in C. It is represented as an int internally. So, if you print its size, it outputs 4 if your size of int is 4 in C89, whereas character is actually a separate type in C++. It is not a part of the integral type. So, in C++, it has a size 1 or something different at least, because if there are Unicode characters, the size may be 2 and so on. So, if you just run this in C++ 98, you will get an output which is 1. Right. So, you can see that the programmer has written this expecting that the value would be 4, but when you compile it with C++ compiler, the value actually is taken to be 1. Then here I have a void pointer to pointing to a character, and I am implicitly casting that to an integer pointer. Right. So, implicit conversion, this is okay in C89, this is an error in C++98. It's because C++98 does not like this implicit cast of pointer types, because that causes a lot of pain in the programming. Then you have int class assign 5. Now, class was not there in C. So, class is not a keyword, it is not a reserved word. So, in some C program somebody may have used a class as a variable name. There are several keywords which have been introduced in C++, which were not reserved in C. So, the program might use any of that. So, this will be okay in C89, and obviously, this is an error in C++98. So, these are some of the scenarios, a lot more or somewhat kind of comprehensive list and discussion will be available in this tutorial of compatibility, but my core point here was to see that even from a technical perspective of the language specification, it is not easy to build a C program as a with the C++ compiler, considering it to be C++ with seamless operation. Now, when you get compiler error, you are better off, because at least you know that there is some error that you have to take care of. Situations like size of character A is kind of disastrous, because the compiler will not say anything. It will silently build because it is correct code, but the result, the logic becomes different, and that is where your porting issues will be very, very difficult to handle. Now, there are several issues that happen beyond this technical feasibility of building C code as C++. So, obviously, you have seen the difficulties of building C in C++, because C++ compiler is simply more strict. So, you cannot just build, you will need what is known as porting. Porting are activities like I had to include math.h, so I had to edit. I will need to change now the size of character A and its use to a proper way. We will have to somehow make that A explicitly as an integer type, and then take the size off, so that C++ gives the same thing. Now, what happens, porting involves substantial cost. The moment you are trying to reuse the code, because it has a value, proven value of having been correct, tested, used by the community or your customer for a long time, but the moment you change the code, all those values disappear, right, because you have made the code different. The moment I change from size of character A to size of character A treated as int, cast to int of character A, I have made the change, and therefore, there may be consequences of subsequent errors and all that creep in. So, the question is it affordable from the business perspectives? The moment you do this kind of porting, you are changing the code, you need a new test plan for this C code in C++. For the purpose of extensive testing, you will have regression test suites which exist. Those will have to now pass in the C++ compilation. It involves tester time, further cost. Again, the affordability from business perspective becomes an issue. If the C++ code is stable and it is regression tested, even then it is likely to break some existing functionality. That might even break your customer's code, because you may have given this library to the customer for their use in part of their code. So, the moment you convert to C++ and do a porting, then your code might break something in the customer's code which you cannot even test, right. So, business wise, it is not liked by the top management, right. So, building C as C++ is feasible from technical as well as business perspectives only in some select situation, though it is preferred. Right. So, the actual engineering practice will much less do building C as C++, rather it will like to do a mixing, which means the meaning of mixing is compile C by C compiler, compile C++ by C++ compiler and then link the whole thing together, all these .os, right. So, basically what you are saying that we will rather, instead of using G++ for doing this, we will rather use GCC for doing this, which selectively can do the build. So, now we are getting another sense of why we have two different compiler target names like GCC and G++. G++ is building everything in C++. GCC is targeted towards doing a mix. Now, if you do that, the issues will arise as we work with different versions of compilers and link .o files in the translation units and control flows, because the control will not be limited to the C code that you have built by your C compiler. It will be in the C++, will come to C, will go to C++, will come to C, and so on, right. So, as you do that, the question is what will be, where will be main, right? Because if main is one function, so it will either be built as C or be built as C++. That makes a significant difference, because there are a lot of static initialization issues that are handled differently in C and in C++. The static initialization issues are how you initialize your static objects defined in the static scope, whether they are global, whether they are class static members, or they are function local static, and so on. How do you initialize them before main, and how do you deinitialize them after main? So, this is a big issue area which we will have to keep in mind. There could be compiler compatibility issues. So, do not ever use different compilers for C++. Use the same compiler. That's what is preferred. So, if you use GCC to do both, then you are safe that they are not incompatible, because it is the same compiler, two parts of that. But if you use some version of GCC to build your C code and some other version of G++ to build your C++ code or some other compiler, then there may be several issues in terms of calling conventions, definition of basic types, and so on. There may inherently be compatibility issues between C library, right. The C++ compiler provides its own version of C headers. So, the header used by C compiler must be compatible with the header provided by the C++ compiler for the standard libraries at least. The linkage convention, and this is a big heartburn area. I raised this question earlier as to why do you always link by C++. The linkage issues are a big thing which need to be handled. There could be exception issues, because C and C++ use drastically different exception models. Right? If you are not on top of exceptions, you may not be able to realize all of that very well. C either does not use anything, most programs do not use anything, just they do a code involved error checking, or they may use a paradigm known as set jump, long jump kind of, whereas C++ has a full grown exception model. So, how to integrate them is a big question in the mix. Then there are some specific issues like scope of struct. The nested structure, if you have nested structure within another structure, their meaning differ between C and C++, right. I mean, you can look at the compatibility tutorial, go through that, and you will get to know what those things are. So, for the static initialization issue, say they both initialize, C and C++ both initialize static variables. They are constructed and initialized before main, but they have different semantics. In C, the static initializer necessarily is a constant. That is, if I want to initialize I cannot call a function. I mean, this is just to show you, just a trivial function which returns a value 10. If I write it as 10, a constant, then it is okay in the C compiler. So, C compiler will not compile this kind of a code. So, if I want to compile main as C, then we will not be able to write this, which often may be required. I have written this as a placeholder, but if you instantiate any object as a static, then the constructor will need to get called, which is equivalent to the init that I am putting here, just to show you. Obviously, this is okay in C++. So, C++ what it does, the basic difference of static initialization is it generates an additional start function, where all global function calls, constructors and so on are executed before the main starts. And the C compiler does not generate this kind of a start function. So, the main starts as soon as it is loaded, right. So, the lesson that we get from here is obviously C++ does more in terms of static initialization. So, we form the rule number 1, which is use C++ compiler when compiling main, never compile main by C compiler. Okay. This is the first rule you must be following when you are mixing. Then there are compiler and C library compatibility issues, right. So, preferably use a library from the same vendor like GCC, and use same or compatible versions. If it is preferable if you use the same version, so that you do not have issues of mismatch of data type size and so on. Runtime library of C must also be compatible with the C++ compiler. So, if you take from the same vendor and the same version compiler, you will not have a problem. If you have to, if you are mixing in that, then you have to make sure that rule number 2 is satisfied, that is C and C++ compilers must be compatible. Now, linkage is a big problem, because C and C++ linkage conventions differ in the basic philosophy, because in C every function is global, it is in the global space. So, every function name is unique, whereas as you have learnt in C++, a function may have multiple scope. It can be in the global scope, it could be a non-static member function in the class scope, it could be a static member function in the class scope, it could be in the namespace scope, a function may be overloaded, and so on and so forth. So, the name is just an indicator of the function, and then there are several other factors which decide exactly which function is that, which include the name. Besides the name, it includes the complete signature. So, what does C++ compiler do in contrast to the C compiler is that they take all this information, mangle them, kind of encode them into a new name called the mangled name of the functions, whereas C does not have that kind of a feature. So, just to show you, I mean this just to show you, how this what kind of mangling you get. Here is I show that there are overloaded functions in the global, overloaded functions as class member, non-static, this overloaded function as class member which is static, and namespace overloads. So, I have all these overloads which are perfectly valid. All of these different print can exist in the same program, actually in the same code at the same time, right. C++ is perfectly okay with that. So, how does it handle this issue? It does handle this issue by mangling. So, if you look at the names they actually generate, there are ways to access these names by looking at the compilation, by looking at the assembly. So, here is the original function, and if you look at these are, I have given it two different, I mean just to give you an example, I have given you the list from GCC as well as from Microsoft Visual C++, and you can see how the names have been mangled, so that they can be actually distinct in terms of the functions called by the compiler. So, you can see all of these are mangled except for main, because main even in C++ is a unique function. You cannot have another main function or anything by that name. Okay. So, this mangling really makes it difficult, because your C linker does not know about mangling. There is no mangling in C. So, C linker does not know about mangling, whereas your C++ linker will always have to deal with mangling. So, when you want to use a C function in C++ or otherwise, you will have to instruct the C++ compiler not to mangle, and also tell the C++ compiler, if you are using a C function, that is not a mangled name, it is a pure name, which means if you stop this mangling, that means that you are going back to the C style of function naming, which means that you cannot have overloaded names for those functions. So, this is handled by using a specific phrase, linkage specifier, as we say, extern within double quote C, which says that this is what we write inside this is pure C. Link this as C, right. So, if we do that here, you can do it for a single function, or you can define extern C as a scope, and so both of these in the scope will be treated as C function, or you can actually put an entire header as extern C. And again, the problem is this you are doing to help the linker. Now, the problem is C compiler does not understand extern C, because C does not have anything like that. So, you have to make sure that the C compiler does not get to see it, only the C++ compiler gets to see it, because that needs to know that C++ linker needs to know that the mangling is not there or mangling is not being preferred. So, you have to make use of this particular macro from the CPP, we discussed this, which is true only if you are compiling as C++. So, if you are compiling as C++, this 2 comment in the entire scope, and you take cognizance of that, whereas if you are compiling by C, these are just skipped, because underscore C++ is not defined, and therefore, everything is treated as C and is not mangled anyway. So, this is the kind of solution that you can have for this mixed type of linkage, and after that you naturally, with this C++ linker has more information, and it has to deal with the decision of whether something is mangled, whether something is not. So, you leave it to the C++ compiler to complete the linking process, do the linking process. There are other issues, I have put them as advanced, because unless you know these in your language well, you will not be able to understand, but there are issues relating to propagation of exceptions and mixing the exception models. So, exception is a big problem. So, for now I am just assuming that you are not we are not discussing about mixing codes where the exceptions are used either in C or in C++. The basic points I have told here, but in a different tutorial I will come back with talking about exceptions, where I will deal with this particular aspect. So, some of the common code mix scenarios. So, this was so we have three basic rules: compile main by C++ compiler, C and C++ compiler must be compatible, their libraries, runtime, all must be compatible, and third is link with C++ linker, right, and use extern C as and when required to guard. So, with that I have listed here some of the common scenarios. Obviously, how do you call a C function from C++? How do you call a C++ function from C? This is just simple, because you have only global type of function. Here you will have to decide what should be done of all different types of functions that C++ has. So, how do I call a function of each type from C? Then the question is, how do I include a C header file in a C++ project, if it is a system header or if it is a non-system header? How do I use pointer to functions? And finally, last but not the least, how do I manipulate objects in a C, C++ project mix, because C does not have objects, whereas C++ certainly will have objects. So, some of the quick techniques, all are primarily based on few very simple strategies. One is to call a function from C to C++, as we have seen, use extern C. So, you do not actually need to do anything for the C code, just in C++ code call them as extern C, so that when you compile, the .o will be told that these are unmangled names, these are global names, and you can make the call directly from here, and that will perfectly work. But here the C++ type rules are not getting are being used, not in when you compile this, you are using C++ rules, only you have told that these are C functions. So, a function declared extern C cannot be called with wrong number of arguments. In C you can, C++ you can do that, but here you will not be able to do that. So, if you call this as say it does not have a parameter, if you pass 2 parameters, then it will be, you will have an error now, which is unexpected arguments, right? Which is actually fine, which actually makes it safer. Doing the reverse is somewhat of a difficulty, that is, how do you call a C++ function from C, right? C does not know mangling. So, if you want to call a C++ function from C, the name of that function must be explicitly unmingled, right. So, now we have a situation of a C++ function, but for that we say that extern C that function signature, which ensures that the compiler will generate f as an unmangled name, and then from C I can easily call that function. That is not a. So, if I do fi, it will be called with no difficulties, but obviously this will work only for non-member functions, only for global functions. Now, what happens if you want to call a member function? What is the speciality of calling a member function? You would recall that a member function always gets an implicit this pointer, that is the address pointer of the object, right. So, you need to know that, and if I want to kind of make the member function globalized, not having the behavior of the member function, I will need to pass this address. So, the most common and most reliable way to do that is define a wrapper function. That is, if P is an object pointer and you want to call the function f, which is a member function of the class of which P's pointed object is an instance, then you want to make this call. Now, in C there is no way to make this call, right. So, what you do, you define a C unmangled function name, say call Cf, pass the parameter that you need for the member function, but most importantly you pass the address of the object, this pointer of that object on which this call has to be made. So, you can see what I mean the workaround that we are getting on here is the C++ code is as it is. This has been added and you are telling the compiler that link it as an unmangled name. So, treat this as a global function, which it will do, and that to that global function you are passing the object, and this is in C++. So, here I can make a call to a member function and call the member function, whereas in C you do not know about what these are, what this pointer and all these are. So, in C you will have to call it simply as a global function. Now, the question is, what is C star, what will C star be? So, there is a other feature that C++ boundary has provided, that any class can be treated as a struct in C, because class is finally an aggregation. The data member part of it, if you forget about private, public, access specifiers and all that, everything is public in a struct, but it is just a data collection format. So, you in terms of the C code, you declare it as struct C star, which is a C star pointer, but treating C as a struct, which C understands, which I am sorry, too many C's. So, which C language understands this class C, right. So, taking that, you can now have a C function which calls this. So, when you call with this, then on that object the function f will get called, right. So, this is the basic addition to in addition to the extern C, doing proper wrapper function is a basic strategy that you keep on doing to create the plethora of varied C++ function types that you need to call. Anything that you need to call from C, you will have to give a wrapper with a unique name, and C calls that wrapper. C++ treats that wrapper as a global function whose name must not be mingled. So, it is put in the extern C. That is the basic strategy. So, if you have overloaded function, I have two overloaded function here. So, for each one of them, I will have a wrapper which just does the same thing. It just makes a call to the C++ function, but they are global and treated as unmingled name. So, in C you get to see these global functions, the wrapper functions only. You call the wrapper functions as you want, because you cannot have the advantage of having the overloaded name in C. So, you have to explicitly call f I with an integer parameter if you want, to call f d with the double parameter, and correspondingly the wrappers will be called in C++ and the overloaded functions will be invoked, right. So, it is strategy wise, now you have got the strategy. The strategy is to have a wrapper to take the function name to the global space. Now, there are some some caveat that can happen. For example, you are trying to do this, you are trying to define a function foo which takes a function pointer, right. Function pointer is another type of way to call function, and that function pointer is defined here. This code is in C++, and now when you use G to call foo G, you will have a type mismatch error. Why? This is, both of these are treated as unmingled name, right. So, G is a C function to C++, right, which you are passing here, whereas the type def that you have done is not in extern C. So, type def expects this to be a mingled name. Type def expects this to be a mingled name, whereas it gets an unmingled name. It cannot handle it, it does not know. So, the simple thing is to take care of this. All that you need is to put everything in the extern C. So, that now the type def knows that this function pointer is an unmingled name, and this is an unmingled function name. So, this will work perfectly fine now. So, finally, to include the standard library headers, it's you have already seen that C standard library headers are available in C++ in the namespace std. So, that is the C std IO that we have discussed several times. You can the C code could use printf. In C++, this simply becomes std : printf, rest of the functionality remains same. So, care is needed if there is a difference between the C header and the corresponding C++ version, which by rule 2 we have said we must not try to do. The header conventions I will not, I mean this slide I have included in the tutorial just for your quick reference in case you have forgotten, but this we have discussed what are the different naming conventions of standard library headers and how to use what when. So, we will just follow that. Now, the question is if we are, this was good for the standard library or system headers. What if there is a non-system C header, the header that say I have written. So, then you have two cases when if the header is editable, if you can edit the header, then all that you need to do is to parenthesize it in the extern C scope. So, what will happen when that header is included in a C++ file, this macro is going to be true and all of that header, all functions therein will be treated as unmingled name. Right? So, it can you can simply include that header, you do not need to do anything in the C++ side. You know this header could be common between C and C++, because when you use a C compiler for the C code, this particular macro is false. So, it will not see anything, it will see a pure simple C header. Okay. Now, what if the header is C header is not editable? If you are not allowed to edit the header, then you cannot do what we said. So, in that case you do not have a choice, but at your use place, which is the C++ code, instead of including it directly, you will have to include it within extern C. So, that the entire header becomes that is the basic thing you are trying to do, that put everything of the C header into extern C. If the header is editable, it is most preferred to do it in the header itself and use that same header everywhere. Otherwise, you will have to do this inclusion within the extern C in C++ and without the extern C in the C code. Right? That resolves all the. So, these were the different scenarios in which you can mix C and C++ codes, function calls of varied kinds, compilation, linking and all that. And besides the three rules that we have given, the summary is to know that you have to use extern C++ properly, so that all functions can be called between C and C++ as needed. You have to guard extern C with C++ macro underscore C++ macro for C code, and everywhere else when you have the any context of mingled names overloading, you have to use wrappers to specifically provide global names. Right? So, this were the kind of, so here we have looked at our overall requirement and issues of mixing, what are the different problems, and talked about the resolution, the remedies that are possible. Continuing in the next tutorial, I will walk you through a complete mixed code example of a project, which you will be able to actually run on your system and see that you are being able to understand the whole issues of mixing and how to work with them. Thank you very much for your attention. See you in the continuation of this tutorial later.